In our insecure site, there were no checks to ensure that the file type wasn't something potentially harmful to our system. When fixed, the file upload system will only allow JPG, JPEG, PNG, TXT, HTML and GIF files to be uploaded by grabbing the extension of the file and directly comparing with the allowed file types. If we left this unfixed, there is the potential for somebody to upload a harmful script, which could, for example, drop our database. Prior to adding the check, our file upload system allowed users to upload a file of whatever size, which could potentially result in file space denial of service. Our fix involves ensuring that file size is less than 500 kilobytes, which should mean that every file which can be uploaded is of manageable size.
One example of SQL injection is that through passing a field as a subquery, you can dump usernames and passwords into the field easily. This can be extended to extract any kind of data from the database. Another example of SQL injection which we fixed in our secure site was the user being able to sign up as an admin by injecting through the password on our sign up page. We fixed this using an escape function which escapes special characters in a string and creates a legal SQL string that you can then use in a statement. We pass the password through this function and it gets encoded to an escaped SQL string. The attacker can control the dynamic content in a HTTP response using XSS. We fixed this using the HTML special characters function, which converts the special characters to HTML entities. It's an inbuilt function that accepts a string being converted as a parameter, and we pass the snippet title and the code through this function before assigning it to a variable to be stored in our database. By observing the request header we send to the server, we copy the request URL and add it to a different website with a malicious link that has altered parameters. By misdirecting the user into clicking a fake link, we can add custom snippets to the database. This is fixed by adding a CSRF token with every request, which will be cross-checked with the current session to make sure that the request is coming from the same origin.
CSS injection could result in harmful CSS, JavaScript or PHP scripts being inserted into our system, which could result in many outcomes, including cross-site scripting or UI modifications. Initially, an attacker could change the input type for our color selector and insert CSS at will without us checking the input. To fix this, we use JavaScript pattern matching within the HTML pattern attribute, as well as a string length tester to limit the acceptable inputs to just hexadecimal color input. The files which our users upload on our site are saved in a directory with their user ID as the title, and each file is accessible through the direct path to that file. This means that every file is viewable to any user, both logged in and not logged in, provided they know the path to the file. We could fix this issue by restricting access using a .htaccess file in each directory, only allowing access to those whose user ID matches the name of the directory.
We made our own hash function using the salt key and 3 inbuilt functions, MD5, an encrypt function and a base64 encode function. Each time the password is created or changed, it's passed through the hash function to create the hash password, which is then saved to the database. This means that no one other than the users themselves will be able to find the password corresponding to their account.
If a non-admin user guesses that an admin page exists, they will be able to access it. They can then modify the account details of other users. This page is an example of missing function level access control, whereby the admin page should check to see if the user accessing it has access privileges. In our bad example, we never checked to see if the logged in user was an admin, rather we just prevented showing them the page link, thus they can guess it to access it. This can be fixed by checking if the current session owner has access privileges and then redirecting them if they don't. A major vulnerability is exposed and predictable session IDs that can be used to hijack user sessions. An attacker can look at session cookies and, if they can discern a pattern, can modify the cookie to gain access to the system. We fix this vulnerability by adding more entropy to session IDs and making them unpredictable. We also refresh the session token on each page load to ensure that a hijack token expires fast. In PHP, session tokens can be saved with the HTTP only and secure attributes to prevent JavaScript access and SS attacks.